de General Sarmiento, Universidad Nacional de Luján, and CONICET, Argentina.
Bueno, good afternoon. Many thanks for the organizers for the invitation, and I apologize in advance because my English is awful. So if you cannot understand me, please let me know, and we'll continue in Spanish slowly, and will be probably better to us. So I will try to show you some questions that we have when we try to work with ecological networks, specifically with food webs. First, I show you the team. Our group es Grupo de Ecología Trófica Marina de la Universidad Nacional de General Sarmiento. Quickly, Vanessa Salinas, Yara Diamela Rodríguez, Melina Cretas Vinagria, Leonardo Sarabia, Georgina Cordone, Santiago Doyle, me and Tomás Marina. So, we work with food webs. Food webs are representations of relationships between organisms that each to other. It's a graphical representation. A food web is a road map. It's not a traffic map. Is a representation of possible relationships between organisms. But these relationships are not occurring all the time and in all places. Each species is represented by the node and the interactions by an arrow. And these graphs are directed. These relationships have one way because they represent fluxes of matter and energy. In ecology, we have some precursors that think for first time these questions. In particular, Lindemann used the concept of energy pyramids and coined the concept of the 10% law, that is the energy that passed from a trophic level to the following. And this is a constraint that could be consequences the organization of the food web. Another important people, Stuart Pym, Joel Cohen and Frederick Bian, all of them with important work in this field. We are working in Antarctica, in particular in South Shetland Island, in the 25 de Mayo Island, and in a little ecosystem, the fjord called Potter Cove. Here is a scientific station of Argentina. And this is an interesting ecosystem because there is here a lot of species in the bottom of the sea. The context of this system is the local and global warming. We talk about local warming because increment of temperature in this place is higher than the average warming of the planet. These lines are the position of this glacier in different years, from 1956 to 2008. This is a phenomena of glacial retreat, and involve a great amount of ice melting and a great input of sediment in the ecosystem, and the sediment affects the organisms and produce changes in diversity and in food web. The food web of the Potter Cove is something like that. Each node is a species. The size of the node is proportional to the number of connections, and the position, vertical position, is proportional to their trophic level. And the color indicates different kind of species: fish, crustacea, algae, etc.
I'm very new to this. So the levels are very well defined, or somebody might be eaten from people both above and below?
It's defined by weighted average of which species eat. Okay. Okay. We have 3 working lines for the study of detection of trends and sudden change in the climatic system and the water conditions, salinity, temperature, amount of sediment in the input of the cove, and changes in community, because the ice melting produce the availability of different substrate, new substrate, and these substrate are colonized by algae and animals. The other aspect is the ecophysiological responses of a species to the change in conditions, in environmental conditions. And we detect which species are more sensitive to the presence of sediment or to changes in salinity, and how the species respond physiologically to these changes. And the other aspect is the aspect of the construction of the food web and the analysis of the food web, and the relationships that are not trophic. Okay, we know that some species are keys because species that have many connections are very important to the pass of energy from these levels to these levels. Moreover, some species are very seasonal. They have pulses of abundance. For instance, krill is abundant 1 month in the year, and represent a large amount of energy, of food, but is present only 1 month in the year.
Which one is?
Which
one is krill there?
Krill.
Is important or?
I think that is here, probably, one of these. I don't remember, but it's from over there. I show you in more detail the role of krill, but we can construct another webs that are webs are competition graphs where we represent nodes of predators, and the links represent that these predators have common prey. So this is a sort of competition net. These links are not directed, are not arrows, are lines. And we can construct common enemy graph where these species are prey and are linked if they have a common predator. So we can see that it's very, very connected. So this show that energy have many alternative ways to go to up in the web. For example, in this web can be subdivided, and this is the graph of algae, only algae, and the thickness of and the color of the arc indicate more and more common enemies. So the indirect effect of algae over the other algae can be due by the influence of predators. The same, this group are the amphipods, they are crustaceans, and this is the graph of competitions. These amphipods are herbivorous. These are detritivores and, ¿cómo se dice? Carroñera?
Scavengers.
Scavengers.